we're done with the tour with Dynamic with Johnny, and so we're back at his house. And this is a two-stall garage that he has, and he's got his home machine shop that he's starting in here, and he's wanting to learn the trade. And he's asked if I'd help him, and I was more than happy to come over, and we're going to help. I'm going to try to do the best training I can, whatever he needs. But he's already a long ways into this, so I'm going to turn everything over to Johnny, and he's going to just kind of walk you through, show you some of the equipment he has. And I know he's got other equipment coming in, but I'll let him tell you what his hopes for his own little home machine shop will be. So, Johnny.
Hi guys, welcome to my home workshop here. So this is attached to my house. It's kind of my own little residential playground over here. After being at work all day long and watching everybody run all of our equipment, I'm like itching to come and run some myself. So you're going to see in this video or another video is my bridgeport. So this is originally built in 1968. I actually bought this from one of my employees. He needed to put a new roof on his house, so I helped him out and bought his machine, and the machine ran really well. It was something that I was using more and more as I get deeper and deeper into this hobby that's becoming, pretty intense at this point. So yeah, I had the whole mill rebuilt recently. Steve and I were just trying to get everything really trammed in. We're trying to hold some really tight tolerances straight off the mill as far as squaring cubes or squaring any type of material. And then also, making sure slots stay nice and tight and clean and things like that. So we're trying to get it all really, really finely tuned, dialed in. The machine runs really well. So pretty happy with this one. It's a pretty old machine, so it's got its little kinks to it, but overall it's pretty well done, and the rebuild was excellent. As you can see, it's beautiful. Next machine, I have a little grizzly lathe here. I started machining actually about 10 years ago. I bought a small smithy machine for a garage at my old house, and that's kind of how I cut my teeth. Made my first chips on the small little smithy 3-in-1. It was always something I was interested in. I didn't really have anybody in my family or friends to teach me how to machine, so pretty much went at it on my own, just kind of experimenting, and of course the power of YouTube and meeting people like Steve who share all that information online is an incredible resource. So I certainly took advantage of that. So like I said, I made my first chips probably about 10 years ago. So I went from that little smithy. I ended up buying this little grizzly lathe. Turning was really interesting to me in the beginning. It was pretty easy to learn. I was doing some fun things and just trying to learn some basic machining functions. And then once the Bridgeport became available, I got the Bridgeport. So I've had this lathe for a few years now. Quite frankly, for what I paid for it, it's been a great little machine for me. You're not holding any crazy wild tolerances on it by any stretch, but as a learning tool, or people who are not really trying to hold, sub-thousandth tolerance on anything crazy, it's a great machine. It's been very good to me. My recent addition is the Chevalier 618 SP. This is the newest machine that just came, and this was really what kicked off Steve and I's friendship. As we all know, Steve's a master grinder. What he does still amazes me to this day. So when I first got the machine, it ran good. We were having some surface finish problems that I thought was my fault. So I reached out to Steve and was asking for some of his advice. We reached out to a couple of our other friends. Steve actually came down here and ran the machine a few weeks ago, and we're still fighting with some surface finish stuff. Chevalier's been trying to go back and forth with us. We're trying to get it figured out. So I'm hopeful we can do that at some point. But right now, the machine's holding tolerances fairly well. It's just not looking real great. So we're working through that. We're hoping that something just got bumped around in shipping. We're actively working to get that resolved. So the Chevalier's been very responsive. The distributor who sold me my machine has been absolutely fantastic. So hopefully we get this one, dialed in the near future, and we could start really going ham on some tools.
Why don't you show them that dresser that you made?
Oh, sure. Yeah.
That's pretty neat.
So Steve came over and he showed me, I'm sure some of you guys have seen his dresser similar to this one, and the first day we got to talking, and I actually ended up making a similar one, except I made mine adjustable, so I don't have a wrench handy, otherwise I'd show you. But these screws loosen up, and we can go from about 5 inches all the way up to about 7. So if you need to clear a tall part on there, you don't need to lower the head all the way down, move things out of the way. It was just a quick and dirty little fixture I made. I think in the future, Steve and I were talking, we're probably going to do some hardened plates on the bottom just so we don't get it all chewed up on the magnet. This is just 1018 that I had laying around. So this is a super useful tool when you're in there working on something, you're trying to get a fine finish, and you want to make sure you get a fresh dress on the wheel. It's been great. It was an awesome idea by Steve, so thank you for sharing that. But yeah, I mean, my goals, this is a hobby for me. I don't intend on selling anything to anybody. It's all for my personal enjoyment and just kind of a serious hobby. Yeah, I just kind of gotten addicted to the precision world. You know, making chips and making cool stuff was really fun for a while, but after I see some of the tools that I'm buying, and, you know, now that I'm getting more comfortable with my skills, it's like, okay, I could make some of this stuff, and, you know, the grinder kind of unlocked a whole new world of opportunities for me. Instead of having just kind of roughing on mills and lathes, I can actually come in here and do some pretty precision stuff. So I'm excited to keep growing, keep learning. Steve's been an amazing mentor to me so far. He's an amazing person. He answers his phone a million times for me, and we have some great conversation, and, you know, we come up with some really creative and fun ideas with one another. So that's pretty much the small tour of the shop, aside from, you know, 24 by 36 granite plate, you know, traditional stuff. It's always loaded up with Steve's tools all the time, which are amazing. You know, I use them almost every day when I come out here after work. And yeah, I mean, you guys follow me on Instagram. I post some of my tool work on there and a bunch of other stuff that I do. So you can kind of follow along in my journey. And, you know, we've been showing my V-block a little bit on there. We're going to be making another bigger V-block once we get the grinder more dialed in. So I can basically use tools that I can make more tools with. I think that's kind of the goal at this point, just to get my reference materials all set up, all my reference tools that I know are perfect, and then I can make, you know, the world's my oyster from that point on. So welcome to the garage.
What we're going to do is we're going to start now. Now this is flat ground stock, and it's probably pretty good to begin with, but we're just going to do a video demonstrating how to square up the part. We are having a little bit of troubles with the accuracies in our table and with the back jaw, so we're not going to be able to get this as square as what I can get at home, because I got mine tweaked right in. And but anyhow, what you want to do is you always want to start with high parallels. I use either the tallest ones, or I use the second to tallest one. If it's way out of square, you're going to want the taller one. Now this is pretty square. We could probably start with the shorter one, but we're demonstrating it. So what you want to do is you want to take the widest surface area. And the whole idea is what you want to do is get that flat and parallel with these two edges. And so the reason we're going with high parallels is if these sides are running unsquared, we'll never get this part to seat down on the two parallels. And we already know we got some issues in here, so we know we're not going to get that. But what will happen is you're actually using your parallels for that purpose. When you flip the part, we'll cut this one side, we'll flip the part. It's going to be your parallels and how the part seats on there that is going to control how flat you can get the part. So now when you got a thinner plate like this, that's even more important. When you set it down the first time, you just put a light hand pressure, and we'll get your wrench here. You just put a light hand pressure. You don't want to beat that down, just a light hand pressure, and then you tighten her down. The reason is that this has got a bow in it. And you push real hard on a thin plate, you're pushing that bow out. And then you're tightening your table. And then when you loosen, or your vise, you're tightening your vise. When you loosen your vise, then it bows back up. Even if you cut and it's flat, once you loosen, it'll bow up. And that's the other reason why you don't want to take on this first side. You don't want to use a dead blow, because you want to cut the bow out. So that's why you're just putting light finger pressure, so it's touching, and then all that bow is in the part. And so when we cut, we're cutting the bow out. And when we flip it, after we deburr it, then we'll be using the dead blow, because that side should be flat. So Johnny's going to set up, and he's going to cut here, and we may have to address the inserts. I think they're sharp enough they're going to cut, but we'll see. He's using a Miltech.
What RPM do you like, Steve?
Yeah, he's using a Miltech with the super shear inserts. This is the piece of A2 flat ground stock.
And get us close for the touch here first.
Yeah, and what we want to do is we want to Get that tight, and you want to cut with your shell cutters all the way up as much as possible, and use your knee for your Z adjustment. So he's just getting her close, eyeballing it right now. You definitely don't want to touch the carbide if it's not spinning. Now he's just going to come in, and all we're going to do is just take a light cut until it all cleans up. And we know we're having some trouble with the trim and with that back jaw running square, so we're not going to get the part as perfect as what we want. And that will be due to the machine where we're at with it right now.
Knock these birds off. Wheel.
So it's important that you get all the chips taken out. Johnny over there is going to wipe things down.
Tap this one, right?
Yeah, what you can do is you're going to go ahead and tighten it down right now. Get her nice and snug. And on this side now, because the other side that we just cut is nice and flat, and there shouldn't be any bow in the perfect world on that. So now we got it set on the high parallels. He's got it seated down. He's got the vise locked down. And now what he's going to do is he's going to take his dead blow, and he's going to tap this in. And what he's going to do, he's going to feel and make sure that the parallel that is tapped in is touching on both sides, and that's how you're going to feel. Once they're tight, they're not going to move. And you want to make sure that both of them are that way. And you can see you got the back one by the movable jaw. That's tight, but the back one isn't. Is both of them tight now?
Yep.
And so what that does is your parallels are real good and the bottom of your vise is real good. Now, and everything's trimmed in good as you come across there. The bow's already been taken off on the first side. Now this side is just establishing a flatness and a parallelness from this surface with the surface we just cut. And Johnny's got a good habit, in my opinion, right here, and I know people would vary on this, but I like to cut and throw my chips away from me instead of at myself. And so this is why he's winding the cutter over to this side so that the direction of the throwing the chips will be back to the garage wall rather than to himself. And when you hit, just go ahead and wind like 10 thousandths on there. Because for what we're making, that size isn't going to matter that much. Because that is a flat stock, it's already pre-ground, we're just taking the 10 thousandths off, knowing that we're going to get a good cleanup on there. Okay, so if everything works out perfect right now, we cut the bow on the first side, took that out of the plate. When we flipped it over and then we tapped it down on the parallel, and we just took a cut across there, we should have a flat and parallel surfaces on those two surfaces. But we already know that because we're having some issues with the table, we know that that back jaw, if I remember right, that was raised up a little bit, wasn't it?
Yeah.
And so we're not going to be able to achieve that here, so we're just demonstrating the method. So at this point we can pull it out, and then we're going to deburr these edges so that we don't have anything that's going to interfere with our accuracy when we do the next sides. Okay, what we're going to do now, we're going to do the next step. We got this with the machine as good as we're going to get it at this point. And so what we have the widest surfaces now. We got them as parallels we're going to get on this machine. And so Johnny is going to clean the chips out and everything. And what we're going to do is we're going to put the high parallels away. And then we're going to drop this all the way down into the vise. And this is where you want this vise jaw. You want to indicate if your head's trimmed in real good. You want to indicate up and down on here, and you want that to be as dead zero as you can. So your head trimmed in proper, and then the back jaw indicated in proper. Then you can be able to drop this all the way down. And you can use the squareness of this jaw, the squareness of your trim, and it should make this surface here now perfect square if everything's good. Perfect square with the parallel sides we got. And so then we're going to end up with a flat, parallel, and square with three sides. And then at this point we'll flip it over, and then we'll do the other side, and we keep it all the way down in the vise because the squareness that we're going to achieve is going to be, again, how good we're trimmed and how square our vise jaw is. And if those things are good and your cutters are nice, it's going to work great. And
no hammering or pressing on this setup, correct?
yeah, and again, this side, because it's thicker, you could put a little more pressure on it, but if there's bow in that, you still, on this first side, you don't want to hammer it down, you just want to hold it down. You want to have the metal non-stress, so when you cut, if there's a bow in it, like so, you cut that bow out. When we flip it over, and then that's when we can hammer it down, but we don't have parallels under here. If we wanted to use, sometimes I'll take if you got your shortest parallel, John? Sure. This part's not wide enough, but if you had a wider piece, we could use one of these parallels. It's a little bit taller, but my main thing, I want to get that part all the way down in the vise. If the part was wider, a lot of times I'll set the parallels in this direction if they check out good. And by the way, this is a set of Brown and Sharp parallels that Johnny just got, and he was kind enough, he bought me a set as well, so thank you for that, Johnny.
Absolutely.
Real nice set.
Right.
And do you have the smaller cutters too?
I have, yeah.
Yeah, because what we're going to want to do, this is a 3-inch cutter, and so it's way overkill on here, and it's going to be harder on your inserts. So what is the smallest cutter in the Miltech series you have?
I have a inch and a half here, I think, maybe 2 inches.
Okay, so we can
just
even
use a regular carbide end mill too.
yeah. What I would do is a regular, maybe a half-inch or
Sure.
5/8, 3/4, whatever.
Sure.
One, you can crank your RPMs up with a smaller end mill, and then that way you can run your feed rate faster by going with that smaller end mill. If you don't have this calculator, these things are sweet. I just use a handful of the features on here. They're way more powerful than what I use. But Johnny's going to figure this 3/4 inch end mill, he's going to figure out what RPM he needs running at a 375 surface footage. So he's going to plug in the first is the diameter of the end mill, 750. Oops, we need the RPM. This one right here for that.
Like inches per minute?
Yeah. Oh, no, yours is laid out different. Okay, you
This
did
is
right.
Diameter, yeah.
Yep, sorry about that. My calculator laid out different. You did it right.
So 0.75 for diameter?
Yep.
Okay.
And then what you do is you type in, punch in 375,
For SFM?
and that's SFM. And then what you do is you just hit the RPM button. And so it's telling us that we run at 1910. So that's the RPM that we run, and the calculator is nice because you can just almost instantly figure out what RPMs will give you, you know, whatever surface foot you decide to run. That will change based on what kind of material you have. It'll change too is if you're going to be doing heavy cuts or light cuts, and we're just doing light cuts, so it'll give you better life on your cutters and inserts when you get the speed proper.
Okay. Straight down the bottom of the vise again, Steve?
Yep.
Okay.
Yeah, so we're gonna just put this down right straight on the bottom of the vise. The thing of it is, right now we don't have a parallel to set it to. Actually, let's just go ahead and put the smallest parallel in there, because it's gonna raise it up just a little bit, about a ½ inch. You know, so one thing when you use this technique, it'd probably be even nice to have you know, a smaller set of parallels over there, something about half that size, because to get the squareness, you want as much of that going down in the vise as you can at this point. And so by putting a parallel in there, what it does, it allows you to tap it down. What will happen when you tap this down, it may bounce back up, and you might not be seating flat. And without a parallel under there to check to see if it's tight on both ends, so when you tap it, Johnny, it might be tight on that end, but you want to check at this end too. Because if it's not tight on both ends, it's not going to be sitting in there flat. So now he's got to raise or lower the table because he just pulled his part up a ½ inch. So he's going to have to change that. Yeah. So at this stage now, we should have a part that's flat, parallel, and square on 4 sides. And what we're going to do, we're going to use that same 3/4 inch end mill in there. And if your vise is indicated in, nice and good on this back jaw, you'll be able to pull that up on, you know, parallels, probably the second or third highest set of parallels, and just pop it in, and then you can just side mill that. And if your vise is indicated nice and straight, now that side is going to be parallel, flat, and square with your part. And then you just flip the part over, and you mill the other into the length that you want. And then you got a part that's flat, parallel, and square. So one of the things that you want to be careful about, let me see that in a minute. You always want to use your flattest surface. You never want to stick a part that's thin and hold up on your high parallels. You can probably get away with it a little bit. One of our videos, Adam had a part that was up a little higher than I was comfortable with, but he already filmed that. But if it's too high, and the thinner plates especially, you could get in a lot of trouble real quick that way. So like I say, you want to use some common sense, and you want to do these procedures just right, and it will get something flat, parallel, and square with some amazing tolerances or accuracy, depending on the condition of your mill, the tram, everything else. And so, Johnny, are you going to set that up and go ahead and side mill the ends?
Sure. You want me to hold it with the higher parallel, Steve, and cut it this direction, or should I try and go for the long cut?
What you're going to want to do is you want to use 2 parallels. You want to hold it in this way. You can, whatever side of the vise you're comfortable, doesn't matter. But you can get it so that, you know, the second highest parallel will be plenty strong.
Okay.
You know, a lot of times I like it to be sticking up just a little bit out of the parallel, but if it's down lower, I mean, you can even use a ½ inch one, but then your angle got to be long enough that you got to clear your vise and everything. So I like it up higher.
Sure.
And in this case, you really wouldn't have to tap it down.
Okay.
Because the squareness, we're only squaring in the one direction, the other is not going to matter, you know, because what we're establishing with this, we're getting the squareness this way. If the part was taller, you could tap it down because you got a squareness that goes this way, but that's where you got with your end mill. If your end mill's not a good sharp end mill and it's dull, it's going to be flexing. So this method will work real good for getting it square in these two directions, but the condition of your end mill is going to determine in the thickness of your part how square it's coming out that way. But we'll show you another method after this that you can use on there for different shaped parts. So the side milling works pretty good for thin parts.
Make sure your parallels aren't sticking out.
Yeah.
Don't ask me how I know that.
And on top of that, the other thing too is when you got these thin parallels, a lot of times when you're tightening them down, you want to make sure that they're not sticking out here. The one thing that is, if you don't tap it down there loose, and if there's vibration, it can vibrate in your cutter. So it's not going to hurt to tap it down, but it's not going to be necessary. You just watch for that. The other thing that you can have, if your parallels, you don't see it, but your parallels can kick sideways like that, and then that creates its own problems too. In this process, you're safe to tap it down on both sides if you want to. That little thin section, it's not really going to be that necessary. There's very little surface on there. Johnny took a heavier cut when he's conventional mill, so that's proper. And he's taking a light cut when he is climb milling. Because what happens with the table loose, if you climb mill and you take a heavy cut and you're slopping the table, it's going to pull the part at you, and it's going to, a lot of times, will just break your end mill. So the procedure Johnny used out there was a good procedure. Do your heavy cutting with the conventional mill, and then do your finish cut real light with the climb mill. The climb mill is going to give you a better finish. Okay, so at this point, then you can just deburr the edges on there, and now, again, if you got a good setup, your tram is good, that back jaw is good, which we know we're out a little bit here, that part will be extremely square, parallel, and flat. It's one of the fastest ways that I know squaring up, and one of the most accurate ways. There are other ways, and if your back jaw is not running parallel, one of the methods that people will use, let me grab another block here. and you'll see this a lot of times, is they'll drop the part all the way down in the mill, on the vise. They'll clean this side up, and then they'll flip it over here. They'll clean this side up. They flip it over and clean up here. But if your jaw's running out of thousandths, you compound that problem every time you flip it. And so in the end, your block is going to be magnified. If that's a thou off there, it's going to be 3 or 4 thou of square on that last side because it's compounded every time. So the other thing that you have is when you have a block like this, let me go to the other side here. On a block like this, you don't have all of these sides look about equal. So basically what you're going to do is you're going to just pick up 2 sides. You're going to do the same process, and you're going to tighten it down, and you can take a cut across there. With something thick like this, very likely you're going to have bow in it, but you just follow the same process and go. The thing you got to be careful about is if you got thinner plates and taller plates, you got to be careful when you go on tall parallels because you can knock them out. But you'll be surprised, we're holding a 1/4 inch of the stock, you'll be surprised at how strong of a hold that this will actually have on there. So in a case like this, it's going to be unreasonable to side mill. You're going to have a long end mill, and that end mill, the pressure that it's going to be pushing just on the end mill and trying to side mill, by sticking this out on the end, the amount of pressure that you're going to have the side mill, that is going to be tremendous. It will never come out square in this direction here. So one of the methods that we'll use the same method that you just saw to square up everything except the last 2 edges. And Johnny don't have this finished yet. He's working on a 45, but he's going to grind that so it's a nice 90. To get the last 2 edges then, you can have a piece set in like so, and you can drop it all the way in, and you can hold it there with that 45, and you can tighten it up. And so if I got a 90-degree here, my back jaw's good, I'm square that way, and I'm square this way. And then you can take a cut. And if this side's been machined already, you know that it's square this way, and then you know it's square this way. And if you wanted to go through the extra time and your head was trimmed in real good, you can throw an indicator on your quill and run that up and down the side at the same time to just get that extra 1/10 or 2. But most of the time, if you hold this right, it'll be within 5/10 square almost every time, unless you got some dirt or something slips as you tighten it up. So this method on bigger blocks is how you'd square those last 2 edges up.